Hey, thanks for tuning in. This is Kelly with Ready Set Drone. I'm here today with Jason, who's also with Ready Set Drone. And Jason is going to give us a pretty detailed explanation of batteries, LiPo batteries in particular, and how they relate to our RC hobby. Best practices around safety, best practices around finding the right battery for your current or the quad that you want to fly, and kind of just help us understand all the confusing numbers and things in it. We are going to do a long and a short version of this video. The one you're watching now is the long version, which has a lot of detail. It's got slides, so if you want to check this thing out and really get to understand how these little guys work and what the differences are, then listen to what Jason has to say. Thanks for being here, Jason.
All right, thank you.
So, first of all, lithium polymer. What's the big deal with lithium polymer or LiPo versus regular batteries?
Sure. So we're talking about all different types of rechargeable batteries here. Most people are used to your traditional type of rechargeable batteries, which are like your AA's and 9 volts, and those are nickel cadmium or nickel metal hydride batteries. Lithium batteries are very popular in RC racing for a couple of different reasons. Primarily, there's the lithium polymer ones are very popular in RC because of the amount of charge they can hold, the amount they can discharge, and most importantly, how you can shape them to fit in certain aircraft. So first we want to talk a little bit about the difference between different lithium type batteries, because you've heard of lithium polymer, you've probably heard of lithium-ion, which is really popular in computers and that sort of thing. So I have an array of different batteries, and we're going to talk about those in a second. But first, let's talk about lithium-ion, which is what you would traditionally find in a lot of consumer electronics like laptops and that sort of thing. The biggest difference is basically how the chemicals inside them work. Lithium-ion actually has an organic liquid-based electrolyte in it, and that's what it uses to transition and move ions, which provides your charge. They typically are encased in a hard shell, like your laptop batteries and that sort of thing. Lithium polymer actually uses a polymer. That's where the polymer comes from. So it's more of a sheet of a chemical that it uses to transition the electrons and provide your charge. And what that lets you do is, if you ever look at, typically they're in soft shells as well. If you were to ever take one of these batteries apart, you could actually unfold it into a long sheet. And that is the polymer. The polymer is nested in between those sheets. And so because of that, they're almost always in a soft shell case. And also it allows them to make them in many different sizes and shapes. As you can see here, we have everything from, this tiny single cell, 3.7 volt, all the way up to, 3 cell. This is a 5200 milliamp battery, but they make them much, much, much larger. But it is in a soft shell, and all batteries are technically volatile. These are a little more susceptible than others, and we're going to talk about why. So you do need to take a lot more care in how you handle them and store them, and we're going to talk about that a little bit later on.
Okay, and I noticed these all most of them have 2 connectors, and some of them have just a single connector, like this small one here. But what's the difference in these 2 connectors, and what purpose do they serve?
Sure. So let's talk a little bit about the different types of electrical connectors you're going to find when you jump into this hobby. And we're going to start small and work our way up. What I have here is called a Jst Connector, and you will see these all over the place. These are for lower amperage use, and we're going to talk about amps here in a bit. They will handle 12 volts of current, but they are typically designed for accessories and that sort of thing. So when you get into this and you start hooking up LEDs and even cameras and all that sort of thing, you're going to see these quite a bit. They're very convenient. They're small, but they are thin wires and they're small connectors. Generally, the stronger the current or amperage of your battery, you need thicker wires. You need bigger connectors to handle that amount of current and heat and that sort of thing. So you'll see these all over the place. Again, very common for your LEDs and that sort of thing. You'll also might see what are called Dean's connectors, and they're sort of T-shaped. These are not nearly as common as they used to be. They were really popular when helicopters came out. You will occasionally see them. Most consumer LiPo batteries that you buy don't have these on it.
That's what's on my SEMA X8C.
Yeah,
the
exactly.
That the SEMA takes.
Exactly. So, strange choice. There's a ton of different connectors out there. There is one that's the most common we'll talk about in a second. You do come across these. All of these you can buy adapters. If you wind up buying some off battery and you're staring at it going, I don't know what to do with this, you can identify it and you can find some sort of a adapter or converter for it. You might also run across what's called an EC3 connector. which is this little guy right here. They're typically blue. And they look very similar to the XC60, which we'll talk about here next, but they are different. You notice there's a very different shape. There's a circle on top and then kind of a D shape on the bottom. They will not plug in very easily to an XCC connector. You can kind of force them.
It can be done, though. I have done it before.
You can force it, but, you know.
Not a great idea.
Yeah, exactly. These were popular a while back as well. They've sort of lost their popularity. The last one we're going to talk about is really the one you're going to find most often. But these do handle both Deans, the EC3s, and the XC60s handle much higher amperage, 30, 60 amps and up and that sort of thing. Typically, you also see they come with much thicker wires.
And these kind of evolved from the days of cars, right? I mean, RC cars,
Sure.
RC trucks, a lot of them use these type of connectors, and now that we're into quads and helicopters and stuff, it's changed.
Yeah, exactly. The last one, the one most of you guys will run into, is what's called an XT60. And it looks a little bit like this. They're always yellow for the most part. I don't think I've seen anything that's not. I've seen some black ones occasionally. Of course, all these have both male and female, so you have to pay attention to which ones you're getting. The batteries will always be female. So typically when you wire it up to your remote control vehicle, you'll have a male adapter, which of course you can solder. They have these nice little solder points on the end of them. They make them relatively easy to do. Also, when you're doing that, you probably want to get some kind of heat shrink to put on the end of it, which is very common. You can see I've got one right there. That way it's not exposed as much as possible. But these are the most common ones you're going to find. They have them everywhere at hobby shops and online as well.
Yeah, you can order them on Amazon, like get 10 of them for $2 or $5.
Yeah,
So.
exactly. So there's other types of connectors, but these four are the most common that you're going to run across. And again, the yellow one being the one you're going to see everywhere.
So, Jason, with this balance port, when you plug this into one of the fancier chargers or even into a simple $8 Traxxas balanced charger, what is it doing? And why is it important that you can monitor each of those cells?
Right. So in a healthy battery, ideally all of those cells have about the same amount of charge inside them. If one is way off, then that usually means something's wrong.
Okay.
The battery is starting to have problems, or there's a problem with that cell. Usually at those points, sometimes you can recover those, but usually it's time to think maybe that battery's a little sketch. And ideally, when you're using it, because these cells are wired in a series, right, they're all chained together, they should be discharging at about the same rate.
And 3.7 volts is sort of the standard nominal voltage for one cell,
yes,
right?
Yes.
Okay.
And then we'll talk about that in more detail here in a bit. But again, so the balance connector, very important when you're charging. We'll talk about that here in a moment, but also can be used to power accessories, battery meters, and that sort of thing.
And one thing, I'm going to throw you a little curveball. I have noticed balanced chargers can be different widths.
Yes.
So like these two have a different width.
Sure.
What's that mean?
That's all about how many cells are in the battery.
Okay.
This is a 3-cell battery. This one's a little thicker. It's a 4-cell. And obviously there's going to be more wires because basically you've got a ground and then you've got a wire to each cell. So here you see we have 4 wires because there's 4 cells.
Plus a
cells.
ground.
We have a ground plus 3.
And so one of the confusing things that I think we'll get into this in a second, but just when we're talking about cells, when the C rating, like a 25C or a 30C battery, doesn't have anything to do with the cells.
Nope.
It's the S. So when you say a 1S, a 2S,
doesn't make
a
any
3S,
sense, does it?
Well,
I got a 20-cell battery.
I read it. The reason it's because they are wired in series. That's what they're talking about. So 3S means 3 cells in a series.
Yes.
So a 4S. So when that S rating is very important because that ultimately is going to be a big compatibility thing with whether your engines and
definitely
ESCs can handle
definitely important when you're buying a battery. You need to make sure you're buying the right cell for your setup. You don't want to get too little or too much depending on what you've got set up, and we'll talk about that here in a moment. We can talk about voltage and that sort of thing. But I thought it might be kind of cool to do a brief overview of some general electricity principles because it does get confusing when we start talking about ratings and we see amps and milliamps and C and all this kind of stuff. It helps to understand some basics. So the voltage, the technical definition, is the difference in charge between 2 points. But we commonly know, hey, it's a 12-volt battery, it's a 5-volt battery, and that sort of thing. But basically, if you're saying between point A in a circuit and point B, this thing's going to provide 12 volts. That's the difference in charge between those 2 points,
usually,
right?
well, not usually, always. Point A is the negative because the electrons flow through
Right.
and discharge to the positive.
Right, right.
Okay.
Current is the rate at which that charge flows. And we're going to use an analogy in a minute to water and hoses and that sort of thing. It'll make a lot more sense. But current is measured in amps, and that is the rate at which the electricity is flowing through it. And the last piece is resistance, which is the tendency of any given material, in our case wires, to resist the flow of that current. And again, this will help quite a bit when we talk about
measured in ohms.
Measured in ohms, exactly.
And just a small thing, my dad always told me the volts won't kill you, but the amps will. It's
Exactly. This is how people can like play with Tesla coils and things like that.
High voltage, low
high voltage,
amperage.
but low amps is like getting hit with a lot of water through a very very tiny hose.
Yeah,
Right.
yeah.
It's the combination of the two. There's a relationship between them as well as resistance, which will determine how bad it is. So if we use the analogy around water and pipes, the actual amount of water is the equivalent of the charge. The pressure of that water is equivalent to the voltage, okay? And the flow of that water is equivalent to the current, or amps. And then the width of a hose or pipe is equivalent to resistance. So we'll talk about each one of those in a second. Let's talk about voltage. Of course, it's measured in volts from Voltaire. The difference in charge between 2 points, it's analogous to the water pressure in a system. So again, think about, you take a shower, you use your garden hose. The pressure of that water as it comes out is equivalent to voltage, right?
Okay.
And the voltage lowers as you run out of water, right? If you think about a storage system where maybe I have a tank hanging,
Right.
above a hose, as I get less and less water, I have less pressure backing that
Right,
up.
right.
And so that's the number of volts.
Okay.
So in our case, as a battery starts to drop in voltage,
volts go
I'm
down.
kind of losing water pressure, right?
And that's why there's a variance between the voltage that you start with
Yes.
when you start flying to the voltage you go down. And at a certain point, you don't want to overdrain the battery.
Yeah, exactly. So moving along that, when we talk about current, that's measured in amps. And that's the actual amount of electricity that's flowing through it. So back to our water analogy, you've got your pressure, how hard that water is actually coming out. The current is how much water you're actually getting,
Okay.
right? And these are measured in amps. So low amps, you're getting a little bit of water. High amps, you're getting a ton of water. Right, and so it's a very easily analogy to remember. Now it also relates to resistance, right? So if we think about the hose mentality, if I've got a very thick hose and I've got a ton of water, a lot of voltage, a lot of pressure behind it, right? The rate that comes out is going to be high. I'm going to have high amps if it's a big hose because I have very little resistance, right? If I put a kink in that hose, I've lowered the resistance. I still have the same amount of pressure. I still have the same amount of water or voltage, but it's coming out at a much lower rate because I've kinked the hose or I've made it a tiny hose. Right?
I'm having a hard time not cracking up with these comments, but yes.
Yeah. You could have some fun with the analogies.
Okay.
But that's an important thing to think about. And we're going to talk mostly about current and voltage when it comes to batteries because resistance is, I don't want to say futile, but I guess I just made that joke. But not as big a deal when we're talking about these. So let's dive in and talk about how that translates to actual batteries. So we mentioned cells, right? We talked about lithium polymer. It's a series of really fabric that's sort of bundled up, and each one of those is a cell. They break them into tiny pieces. If I were to unwrap this, there would actually be individual bundles of this stuff sort of wired together in a series.
Okay.
And like you said, that's represented with an S on the battery.
Right.
Okay.
So 1S battery, 2S.
Yep.
So that's a 1S.
This is a 1S.
Yeah.
Right. It's even labeled on there. You see a 1S on there, and it's tiny. This is for a SEMA quadcopter, and it's a 1S battery. It's only got a single connector. We don't have a balanced charger because we don't need to balance charge this. It's one cell. Right.
Oh, I often wondered why that one didn't have. That makes sense.
One cell.
So and it's weird because I don't know that I've seen very many 2S batteries. It seems like it jumps from 1 to 3
The
pretty
Fat
commonly.
Sharks are almost all 2S.
Oh, okay.
Yeah, the batteries, the little batteries.
Yeah,
in
the
your
little
goggles.
black ones. Okay, cool.
Yep,
Got
those
it.
are 7.4
And then
volts.
this is a 3S, and this is pretty common in mini quad
Yep.
racing quads, right?
Yep.
Okay.
So every cell provides a nominal voltage of 3.7 volts. We're going to talk about what nominal means here in just a second. But again, we have a 1S here, 2S, like you find in your Fat Shark. A lot of transmitters. Radios will have 2S batteries in it because they don't need more than 7 volts. It all depends on the electronics and what how many volts it needs to operate.
Right.
But those are quite common. And so here, all 3 of these guys are 3S. So we've got this guy, we've got a longer one, we've got something more common like you'd find inside a Phantom quadcopter, and then something much larger like you might use on a Hex.
That big one's a 3S as well?
It's a 3S as well. And then we have this one, which you can see is actually thicker than any one of these guys, and this one is a 4S. So this one has got, obviously, just got more stuff packed in there.
And again, S means, just if you're going to have a key takeaway, S means the number of cells that are wired in series, and that's why it's S instead of C.
Exactly.
Okay.
So if you do the math, and the nominal voltage is 3.7, this is 3.7 volts, a 2S would be 7.4, a 3S would be 11.1, and a 4S would be 14.8. Now,
look at the brains on this guy.
Yeah, I know. Math is hard.
All right. So C ratings, you were talking about, you would think this thing would have a super high C rating, but this is actually only a 10C battery.
Right. It's a larger battery. So the C rating, again, not to be confused with the C in measuring a charge. The C is really a multiplier on the amount of current you can safely draw out of the battery at once. And so in order to do that, if we say we had a 1500, and we're going to talk in amps instead of milliamps, if we had a 1500 milliamp battery that was rated at 20C, we'd take 20 times 1.5, and that means we can safely draw 30 amps out of that battery.
Okay.
And that means everything all at one time, right? All of your motors and everything.
So your motors would have to be about 7.5 amps each.
On average. And actually it averages about out to that. Again, most motors you can find spec sheets on them, and it will show you at what their amperage rating is at different RPMs and that sort of thing. So that's kind of how you do the math. And if you're trying to size, if you really wanted to get geeky about it, you would try to calculate your total maximum current draw by looking at your motor specs and what everything else is going to draw, and do the math. Look at the C rating, multiply it by the amp hour size of the battery, and that would give you your theoretical maximum. Now, a lot of these things have what they call burst rating, which basically means you can safely go up to that C rating for about 10 seconds at a time. And you'll see this. You'll see some that'll say it's a 25C with 50C burst. Okay. And again, like I said, all the numbers are theoretical maximum, but those have been tested and rated and proved to be relatively safe, to go up to that high of a current draw for that amount of time. Okay. So let's talk a little bit about how this relates to the real world, and really the one thing we care about the most is our motors, right? We care about how much they can handle, how fast they're going to spin, and that sort of thing. And that's very closely related to voltage, and we're going to talk about RPMs. So the higher voltage battery you have, the faster the batteries are going to be able to, or the faster the motors are going to spin. Okay. So this brings us to another confusing term that a lot of people don't really understand, but it really relates to everything we're talking about, and that's kV. Right.
Not kilovolts.
There's not kilovolts. It is actually a velocity constant, and again, it's kind of like the C rating. It's another multiplier that you use to determine how fast the motors are going to spin in a given voltage. So these are Sunny Sky 2300 kV motors, and so if we take these and run them on a 3S at say 12.6 volts, theoretically at its highest charge, we would take 12.6, multiply it by 2300, and the fastest those would go would be 28,980 RPMs, which is pretty insane.
Yeah, that really
is. Again, that's at its highest. Obviously as you adjust the throttle, it's going to change depending on where you're at. The other thing too is, depending on how fast they're spinning, they're going to draw more or less current, which goes back to the amps and how much juice you got in your tank. Right. So this, you start to see how it all relates together. Now this is why 4S has become very popular, because this gives you around 14.8 volts nominal, which means the motors are going to spin faster. Some motors will say whether or not they're rated for 4S. Again, it's just whether or not they've been tested. These Sunny Skies do not say 4S on any of the documentation anywhere. It works very well. Yeah. Again, sometimes you just have to test it and see how hot the battery is, how hot the motors are.
So you're not going to blow your motors up right away if you plug in a 4S and it's not rated for it.
Not necessarily.
So it's really all about how you fly it, and if you're testing, it's a little bit of trial and error.
What you can blow up is other components in the system that are not designed for more than 12 volts. Right? Okay. So like cameras are a good example. Most cameras these days actually accept a range of voltage. Some of them will go from 7 to 20. Oh, wow. So it's safe. Okay. But sometimes there are components like LEDs is a good example. Maybe your video transmitter, if it's really twitchy, if you feed it more than 12 volts, it it will fry it.
Okay.
And this is where you start to have components in your copter that will actually step down the voltage between, like this is a Strider frame, and it will take a 4S battery, but it has components soldered into it that give you connectors that provide you 12 volts.
Like resistors.
Yeah, essentially.
Okay.
Yeah. It brings down the voltage. So that's how kV, and that's how it relates to voltage. So again, if you you can do a little research if you want to go all out and start flying a 4S build. Make sure you've done your research. You get the right speed controllers and motors, and find people who've had success with them. Like the ones I have here, a lot of people have had success, and you can use a higher voltage battery and just kind of go crazy, which is quite a bit of fun. So let's talk about safety.
Yeah, you hear about people getting on airplanes with LiPos and they blow up, and aside from drones attacking everyone and taking over
the last
world,
thing you want to do is burn your house down.
Yeah, well, and
sort of
it's bad press and it's not safe. So
Exactly.
what can we do to be safe with
Sure.
these things?
So like we talked about in the beginning, these are almost always in a soft shell.
Right.
Which is bad in it itself because they're prone to punctures and drops and that sort of thing.
And if you do puncture one of these things,
it will start to do stuff.
Yeah. Again,
it will start to chemically react.
Watch YouTube, and you can see
which means
what
it heats up. Now, let's be fair. Most of the videos on YouTube are people trying to be ridiculous.
True.
So what they'll do is they'll overcharge them. They'll turn off all their safety mechanisms and overcharge them, and the battery will start to puff up, and they'll be like, "Hey, watch this!" and they'll hit it with a hammer or something, and it will, if it's overcharged. And they puncture it, it can flame up. I mean, it can almost kind of explode. I've seen some pretty crazy ones. That being said, if you don't go that far, if it does get punctured or crushed, it can start to heat up and will smoke. I mean, the federal aviation rules, you actually are not allowed to ship these in cargo. You can actually, if you carry them, you actually have to take them on board on the plane as carry-on luggage, and they have to be prepared and packed a certain way because getting damaged or punctured or crushed is the biggest problem. They can heat up and start to, they can cause a fire.
Yeah.
Which is bad. So relating to that is, first of all, if you don't have one of these, I would highly recommend getting one of them. These are LiPo-safe bags. They're just really fire retardant bags, flame retardant bags. They're not necessarily gonna solve everything, but it is a very, very smart thing to have. At the very least, you should store your guys in this. I've seen a lot of guys, and I will try to do this, they will actually charge them with these guys in there.
Yeah,
So
you're
you
not
can
supposed to leave LiPos alone when they're charging either.
Yeah,
right?
exactly.
I mean, I can tell you many times I've started several batteries charging in my garage, and then I go in the house and forget about them
Everything
until
will
the
be
next
fine.
day.
Yeah,
I
exactly.
haven't had an accident yet.
Yeah.
But
So, it's one of those things, like everything's fine until it's not, so a little bit of paranoia is not a bad thing. I've seen guys that will even put them in these bags and then put them inside cinder blocks, like in their garage, and maybe even cover it with like a paver with just some room to breathe, which is the far end of the spectrum, but that's actually pretty smart.
yeah,
I mean,
if something happened, it wouldn't. There's no way that it's
yeah,
going to catch your house on fire.
if I have a whole bunch of them crammed in here and one of them starts to heat up, they could all go.
Yeah.
You know what I mean? So like having them somewhere safe or in your garage or away from outside is probably not a good idea because it's too hot in most places. But storage is important. Not overcharging them is important, right? I would highly recommend you invest in a decent charger if you're going to get remotely serious about this activity. These can range in price from 70 to 150 or 200 plus. But these are really nice. They have LED readouts on them. They'll show you exactly what's going on. There's all sorts of options in there. I can even safely discharge my battery through something like this, which is
a
really,
lot of these
really nice.
times, don't these discharge first and then charge?
No, they don't ever discharge first, but they have a discharge mode where if you do have a battery that goes bad or it's just not doing its
then
job
you
anymore, you
discharge
discharge it.
and
yeah.
recharge it, and sometimes that'll
Exactly.
fix the problem. Okay.
But all of these will have the balance connectors that we've talked about, right? And there are different widths in there for different cell-sized batteries. But these will also show you, exactly how much current is going into it. You can. Another important thing is the rate at which they charge is important. You will sometimes see a C rating on these for their charge rate.
Oh, really?
Yeah, sometimes. It's not printed on any of these, but sometimes you do see it. It's another marketing thing. Sometimes batteries can safely be charged quicker than others,
Right.
and they'll say,
because people want to get back to flying, so
Yeah.
they're trying to charge them
Exactly.
quickly.
So they will have a C rating as well. As a general rule of thumb, 1 C or 1 multiplier is what you want to charge them at. So this is a 1.3 amp hour battery. I would want to charge it at no more than 1.3 amps.
Yeah, and you can't you can't go wrong by picking a slower
A
charge
lower,
rate.
yeah. It'll take longer, but it's safer.
I remember that was a problem or something I was confused about when I first started flying, and I had a bunch of Blade helicopters, and they have these little tiny LiPos,
Yeah.
and learning that, you know, I was always safe to just put it on the lowest charge
Right.
rate and let it charge
Right.
versus pushing it too hard.
Right, exactly. So again, that's why these kind of chargers are really, you can actually tell it exactly how many amps you want to put back into it. And remember, amp is the amount of current we're putting back into it. So I wouldn't want to take a 1.3 amp and then throw it on a 3 amp charger. That's how the guys on YouTube get their batteries to the point where they
blow
can.
up?
Yeah, exactly.
Gotcha.
They'll turn off safety mechanisms because these guys with the balance chargers will tell when it's fully charged and they will stop charging. Now, every charger does that. If you have a cheap one, that can be questionable. If that mechanism fails, it's just going to keep throwing current into the battery,
Right.
and that's really
could
bad.
heat it up pretty
Yeah,
badly.
and catch on fire, which is why you don't want to leave your house.
Okay. What about discharging?
So discharging is another important point. In general, because these are somewhat, delicate, you don't want to over discharge them.
Meaning, because I know back in the day, I had do a lot of video work, and the video camera batteries we had were nickel cadmium, I think, NiCads.
Yeah.
And you had to actually run them all the way down
Yes,
before
'cause
you
of memory.
recharged them
Yeah,
because
yeah.
of battery memory.
Yeah,
That's not
exactly.
the case with these.
Not the case with these. And the problem is that if you take too much out of them, because remember, there's polymer in here and it's fabric and that sort of thing, it will dry up and shrivel. And it will
Physically.
start, it will damage the cells and cause you not to be able to charge it back up. Or it could cause it, if you hear about puffy batteries,
Yeah.
that anytime there's damage or it's been over discharged too much, they'll puff up. And anything that looks abnormal. I mean, this one looks
a little puffy.
It looks a little puffy, but they tried to cram a lot in here so it'd fit in a Phantom, which is why this one's a little puffy. This one's actually still safe because I compared it to my others. You'll have several of these, and one will look like a melon.
Yep.
Right.
Yep, I've
it's
seen
time to
those.
get rid of that battery. Ideally, you don't want to just throw it in the trash. That's really not safe.
Yeah, most cities have a recycling program.
Yeah,
where they'll
it's going to a
take
dump,
hazardous
but
waste.
it could catch fire. Again, if you get a good charger, you can safely discharge it with one of these guys.
So it's a good idea to discharge it before you dispose of it.
Yep, and then you would want to cut the leads and just wrap it in something, and then you can throw it in the trash, right? But yeah,
Or take it to a hazardous
or to a
waste.
recycling center, exactly. Again, they're a little delicate. I would just recommend to people, don't take it for granted. At the very least, these are cheap. I'd get 4 or 5 of these guys and at least keep your stuff in that if you're going to keep your stuff in your house. Again, if you think about it, I mean, hobby shops have, hundreds of these sitting on shelves. Spontaneous problems with them are extremely rare.
Right.
But if you overdo it or,
Or you're keeping them in a hot garage or an attic or something like that,
yeah.
that could be problematic.
Yeah, exactly. But yeah, other than that, there's a couple last-minute things to mention around some accessories you might want to get. We talked about beepers that you can put. This guy doesn't have it because it has one built in. But beepers you can put on your mini quads. Those are great and they're very inexpensive. Having something like this is really handy, and this is just a general battery checker. And I can essentially plug the balance connector into it. And at any given time, I can see the health of the overall battery.
In each of the cells as well?
Yeah, exactly. So this is telling me there's 16.7 volts in here. So again, the nominal voltage on a 4S is 14.8. Fully charged, I'm at 16.2. Tells me how much percentage is in there. I can actually check each cell, and it will show me, the charge of each one. And again, we're seeing about 4.1. Which is about right.
And what is this thing called? Just a capacity controller?
It's just a LiPo battery checker. Yeah.
You can get them on Amazon.
You can find them everywhere. Hobby King, Amazon. Again, this will actually read multiple different battery types, as you can see here.
Okay.
But I have it set to LiPo. These are really, really handy if you're out and you have any doubt about the health of your battery.
So if one battery is way lower than the other two, then you know that battery's got a problem.
Exactly. Like if you ever check one and it's got like reading 8 volts or something and it's a 3 cell, you've probably got a bad cell.
Okay.
So these are really handy. You'd go through it and one would be like 3 something, and one would say 1. And you're like, oh wow. Sometimes a really good charger can repair those. But most of the time I would say it's questionable.
Okay.
I wouldn't go too crazy trying to save the battery. It's $15, just get a new one.
Yep.
And then the last thing is one of these, which is actually a battery load tester. And these are actually really kind of cool. If you're a science nerd or you really want to geek out on how much energy your craft is actually drawing, you can actually hook this in between the battery. It will show you voltage, amps, all sorts of good stuff in real time.
Will you just take the propellers off and spin the motors?
You take the propellers off, or you could tie it down with something.
Okay.
Because again, the propellers are going to add load to it. Yeah, exactly.
Okay.
I did that with my Hex. I weighted it down with dumbbells, and I had this in there. Well, some flight controllers, they actually have to calibrate your battery. Because they have some sort of battery monitor in it, and so you have to tell the thing how much is actually getting, so it has some sort of calibration. And these are really handy, and these are very inexpensive too.
Nice. So, Jason, lightning round. Let's see if we can do this in less than 2 minutes. The most important pieces to remember from all of this, and by the way, I think we're going to do a short version and a long version of this video because there's lots of great detail in here, but there's also a few things that if you don't have the patience or the brain capacity to understand all of that, there's probably 3 or 4 things you should understand. Number 1, voltage. What is voltage? What is the difference? It's just basically that's the concept of how much pressure there is, right?
Yeah,
behind the water.
Exactly.
And that's measured in the...
you can measure by the cells is the easiest way. So
3.7
3 cell is your most common. It's going to give you 11.1 nominal voltage. It's what you find in most quadcopter racers these days.
Cool. And then the cells themselves, you've got a 1S, a 2S, a 3S, and that just has to do with how many cells there are. They're wired in series, so that's where the S comes from. The C rating is how much you can safely discharge the battery.
It's how much you can draw from the battery, right? It's a multiplier. It's how much current you can safely draw from the battery.
So, and that's pretty important because it will overheat if you have the wrong C rating. But most of the time, it's something that you can play with and figure out.
Exactly.
And then finally, the milliamp hours. That's again
the capacity, about how much you'll expect to get out of the battery as far as its runtime.
Okay. Well, Jason, this has been awesome. Thank you for taking the time to go through and help us understand all this. I feel like it's the kind of thing that if you really understand these things, you can become a better pilot and also better at building and repairing your quadcopters.
And you can keep your house from burning down. So that's
always good too.
It's a good skill to have.
We're going to do a short version of this video as well. So if you want to check that out for sort of a little refresher, feel free. Also, please subscribe to Ready Set Drone on YouTube and visit our website, readysetdrone.com, if you want a cool t-shirt like this one or any other swag. We don't have as much of it here today as we'd like, but we appreciate you tuning in. Subscribe, and we'll see you in the next video.
Thanks a lot.